Assalamu alaikum. My name is Aqsa Kainat. Today I am going to present the topic lipid metabolism. Lipid metabolism includes digestion and absorption of lipids. The digestion of fats and other lipids poses a special problem because of the insolubility of fats in water and because lipolytic enzymes, like other enzymes, are soluble in an aqueous medium. The above problem is solved in the gut by emulsification of fats, particularly by bile salts present in bile and pancreatic lipase. The breaking of large fat particles or oil globules into smaller fine particles by emulsification increases the surface exposed to interaction with lipases, and thus the rate of digestion is proportionally increased. Phases of digestion and absorption. Lipids digestion and absorption includes the whole process of digestion of dietary lipids, and its subsequent absorption may be arbitrarily divided into three phases: A. Preparatory phase, B. Transport phase, C. Transportation phase. A. Preparatory phase. It includes the digestion of lipids in the intestine. The large lipid particles are broken down into smaller particles with the help of lipolytic enzymes. Now, transport phase includes the transport of digested fats across the membrane of intestinal villus layer in intestinal epithelial cells. Transportation phase includes the events of action that takes place inside intestinal epithelial cells and its passage through lacteals to lymph or in portal blood. First, we have preparatory phase, in which digestion in mouth and stomach occurs. It was believed earlier that little or no fat digestion takes place in the mouth. Recently, a lipase has been detected called lingual lipase, which is secreted by the dorsal surface of the tongue, that is Ebner's gland. Lingual lipase. Lingual lipase activity is continued in the stomach also, where the pH value is low. Due to retention of food bolus for 2 to 3 hours, about 30% of dietary triacylglycerol may be digested. Lingual lipase is more active on triglyceride, having shorter fatty acid chain, and is found to be more specific for ester linkage at third position rather than position 1. Secondly, digestion in small intestine. The major site of fat digestion is the small intestine. This is due to the presence of powerful lipase stepson to the presence of a powerful lipase. Bile salts, which acts as an effective emulsifying agent for fats. Pancreatic juice and bile enter the upper intestine, the duodenum, by way of pancreatic and bile ducts respectively. Now, secretion of pancreatic juice, as we already know that it is stimulated by the passage of an acid, gastric contents, that is acid chyme, into the duodenum. By secretion of the gastrointestinal hormones, that is secretin and cystokinin polysomes. Gastric lipase. There is evidence of presence of small amounts of gastric lipases in gastric secretion. The overall digestion of fats brought about by the gastric lipase is negligible because no emulsification of fats takes place in the stomach. The enzymes secreted uh, the enzyme secreted in small quantity. pH of gastric juice is not conducive, which is highly acidic, whereas gastric lipase activity is more effective at relatively alkaline pH. Now, pancreatic lipase, what role it plays? Role of bile salts in pancreatic lipase activity. Bile salts are required for proper functioning of the enzyme. Bile salts help in combination of lipase with two molecules of a small protein called as cholipase in the intestinal lumen. The combination of lipase with cholipase has two effects. That is, it enhances the lipase activity of the intestinal pH. Secondly, it also protects the enzyme against inhibitory effects of the bile salts and against surface denaturation. Bile salts also help in emulsification of fats. Thank you so much.